Taylor, I mentioned last class that if I've done my job right, I'm not really showing you anything new. And today, I'm not going to show you anything new. I'm going to show you a couple of nasty questions, but hopefully as we go through, partway through, oh, I can see where you're going if I do my job. We've been harping on projectiles. We've been yakking on projectiles. Projectiles, we said the key is components. We said there's three main types. Horizontally from a cliff. John, that one's kind of nice because your initial vertical velocity is 0. In fact, right here where it says pause here, right where it says number 2, what if the projectile is launched horizontally? Come on. Here we go. Right click. Vy initial is 0. Common mistake, because there's only one velocity in the picture, kids want to use the horizontal into a vertical, and my theme is, hey, don't put a horizontal into a vertical, don't put a vertical into a horizontal. Keep directions, 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 directions straight. Oh, and we're never going to use the slanty except to find the components. We said that the second type of question was slanty from the ground components. The third and toughest was angled from a cliff. And that's what we looked at the last lesson. We did angled from a cliff. We broke into components. I actually, in lesson 5, we did number 10 or number 11. I showed you 2 methods, Braden. I showed you one where you found time using the quadratic formula. I showed you another where you found time by cleverly finding Vy final, how hard it hit the ground vertically, inserting a negative because the question gave you a positive answer, and then finding time. But you got to be able to find time from a vertical distance. We looked at finding a velocity. I said the toughest question is going to be, the second toughest question is going to be if I ask you to find a slanty velocity at a given time. The toughest question is I'm going to ask you to find a slanty velocity, and I'm not going to give you the time. We're going to have to figure out the time. We're going to spend most of our time finding time. That's kind of a refresher. Okay, let's look at example 3. Projectile is launched from a cliff as shown at an angle. It lands on the ground 5.2 seconds later. They gave me the time. Because they gave me that, I smile because, Matt, this question is going to be much easier. If they give me the time, the question tends to fall apart and become a careful plug and chug, don't mix up direction. A says find the height of the cliff, the range. And C says, what's the final velocity of the projectile just before impact? Okay. Before I do any of that, is this slanty? I do. Okay. I'm going to break this up into horizontal and vertical initial components. Hopefully this is becoming fairly monotonous. Oh, it's been there. Done that. The 20 is the hypotenuse, Vx is the adjacent, Vy is the opposite. Michael, I'm coming at you. Horizontally. By the way, you don't have to do horizontal first. I think it's just a habit. I do horizontal then vertical because in my mind that's how I say it. Anyways, horizontally, which trig function? Of course it is. So I think when you do the trig, you'll get, well, let's walk through the physics. It's going to be cosine of 30 equals Vx over 20. Ethan, how would I get the Vx by itself, my friend? What will I do with the 20? Okay, so hopefully you're kind of sleepwalking your way through the trig almost out of boredom. Do it carefully, but I hope you're comfy with it. So it's going to be 20 cos 30, and I'll go 17.321 meters per second. Michael, coming back at you. Which trig function is going to be vertical? Sine. Yeah, and it's going to be sine 30 equal. In fact, it's going to be 20 times sine Vy initial. I think this one, if you try it on your calculator, works out dead even to 10, because I think the sine of 30 is 0.5. So 10 even. I really haven't started solving the question yet. Now, the other strategy that I gave you was a T-table or a chart. You don't have to use that. I use that just to keep my directions straight. For what it's worth, if you're careful, Boyana, with directions, you're fine. In other words, I'm going to ignore the T-table, and I'm going to answer A and B and C. Boyana, what does A want me to find? Height is vertical. So I'm going to list vertical data here. I'm not going to do the full T-table, but I am going to say, okay, Vy initial was 10. AY was negative 9.8. And what makes this question nice is I know T, 5.2. I don't have to spend most of my time finding time. And they want me to find a vertical height. Is there an equation that has V initial, T, A, and D in it? Yeah, the quadratic. The D equals VIT plus a half AT squared. Vertical displacement equals VIT plus 1/2 AT squared. And now, Boyana, it's fairly plug and chuggish. I'll be careful. By the way, as a displacement, are we ending up above or below from where we started? What do you think? Are we ending up above or below from where we started? Below. So this is going to give me a negative answer. Height is technically a scalar. If you gave it to me as a positive, I'm fine. If you left a negative in there, I'm not that fussy. I'm fine. So it's going to be 10 times 5.2, 5, negative 9.8, 5.2 squared. And I get a vertical displacement of negative 80.5 meters. So a height of 80.5 meters. And again, if you left the negative on there, Matt, I'm not going to freak out. Hey, Braden, what's B want me to find? Oh, horizontal. So I could do this with the T-table. I'm just going to horizontal, say to myself, horizontal. So AX is 0, yay. VX was 17.321. Time is still 5.2, and it wants me to find that. Help me out, Braden. What can I go with, my friend? I think there's an equation that has those in there. I only have one V. I don't have a VI or a VF. I'm sure that's going to work. By the way, I'm trying to find D, so it's got to have a D in it. So, sorry? I agree and I disagree. Why do I both agree and disagree with Braden when he says the same equation as this one? Yeah.
A is 0.
I don't need to write the half AT squared, right? Okay. So I'm going to go, hey, dx equals VXT. The range is going to be 17.321 times 5.2. 17.321 times 5.2. 90.1 meters. If I go to 3 sig figs. Those two questions, if I give you the time in the question, I would consider these C+ level. What's a B+, A-? Finding a slanty velocity. Hey, Natalie, guess what part C is asking me to find? A slanty velocity. Can you read to me part C, Nat? And velocity, magnitude, and direction. I think the velocity as a picture, and I tried to leave you lots of room, I think the velocity as a picture looks like that. It hits the ground at an angle going down. Might be steeper, it might be shallower. It hits the ground at an angle going down. Did I say angle? What's this a job for? So I'm going to break it up into horizontal and vertical, except I'm going to call this vertical final impact velocity, that one, what it hits the ground at. You okay with that, Dylan? And I know one of these already. Vx is 17.321. Kind of nice. What's Vy final? Often kids will say, isn't Vy or negative 10? That would be if we were starting and ending on the ground. In fact, you know what? I'm pretty sure Vy final is going to be like bigger than negative 10. Can I figure it out? Oh, I thought you were offering a suggestion earlier. Well, Vy, vertical or horizontal? Sorry? Vertical, right? Yes? Okay. Well, let's list our vertical stuff over here on the right. So I'm going to say Vy final, I don't know. I know A vertical, negative 9.8. I know vertical, 10. Oh! I also know 5.2. That's how long it fell for. By the way, I also know my vertical height, and I could use that, but I think it's going to be easier to use this equation here. Because there is an equation that has V final, V initial, A, and T in it. Good old VF is VI plus AT. Before I start crunching the numbers, am I expecting a positive or a negative answer here? It's going down. So if I get a negative, I'll smile. If I get a positive, I'll freak, right? I'm going to go straight to plug in number 10 plus negative 9.8 times 5.2. It hits the ground moving down at negative 40.96, and I'll carry all those because I'm going to use it. And I'll add that here. Mr. Duck, what a deem. What happened to the negative? A deem, look, there's the negative in the arrow, right? I don't need to put it there. Would it be wrong? It would work for Pythagoras. You might get the wrong angle when you go sine or shift coast if you kept the negative in there. Oh, and the theta I'm going to find always where the vector is starting from. And what direction will I give that particular theta? Because we're looking at the side, up is not north. How did we? Okay, we're going to call it below the horizontal. First of all, let's label our triangle. There's the V, Natalie, that they want us to find, the hypotenuse. How can I find the magnitude of V? Well, good old Pythagoras, yes? It's going to be 17.321 squared plus 40.96 squared equals square root. The magnitude of the slanty is 44.5 meters per second at, Michael, coming back at you, Vx opposite adjacent to hypotenuse.
Sorry?
Vx opposite adjacent to hypotenuse.
Oh, adjacent.
What about Vy final?
Opposite.
Which trig function?
I believe it's 10.
I believe it's going to be tan theta equals 40.96 over 17.321. 40.96 over 17.321. And I get, I'll go 67 degrees, 67.1. I take that too. I'll go 67 degrees. Is that right? Below the horizontal. If it was still on its way up, above the horizontal. And you would have got a positive Vy final, which would have told you it was on its way up. I pause. Did I teach you anything new there? Don't think so. Again, being stubborn, being clever, and what else can I do with this? Okay? The only question, Taylor, that I can make tougher than that is to ask you to find, like Natalie pointed out, a slanty velocity, but not give you the time, make you figure out the time. Hey, let's do one of those in just a second. Apparently I left you like a whole extra page of writing stuff. Okay. Note to self, probably don't need that much room. Number 4. Look at 4A. Rylan, what does 4A want you to find?
The velocity.
Magnitude and direction. What does 4B want you to find?
Velocity.
Magnitude and direction. You know what? They're the same question. I'm going to do 4A. If you want to, you can try. You know what? Actually, you don't need to try 4B. There's going to be stuff like that on your homework. Okay? By the way, I think 4A, this is 4A, I'm going to guess it's probably on its way up, and 4B, it's probably on its way down. But we'll prove that by finding all this. Are we launched from the ground or from a cliff?
Ground.
Angle or straight?
Angle.
Dolph, draw a little picture. So we're being launched at 88 meters per second with a launch angle of 70 degrees with the horizontal. That means go horizontal, above. How do you know it's above? Well, if you're on the ground and you launch downwards, it's not going to go anywhere. It's going to hit the ground right away. John, is this slanty? Well, guess what I'm going to do? Yep. Hypotenuse, adjacent, opposite. Coming at you, Michael. Horizontal, which trig function? Oh, sorry.
Horizontal?
Yeah.
That would be cosine.
I'm going to cut corners because I want to give you lots of time to work in class. I think when we cross multiply, we'll end up with Vx being the hypotenuse times the cosine of the angle. And I think we'll find that Vy initial ends up being the hypotenuse times the sine of the angle. I'll go 30.098. And I'll go 82.693. Okay. I haven't even started answering the question yet, but Lydia, you give me a slanty, I'm going components. Rylan, what does A want me to find?
Velocity.
When?
After 4.6 seconds.
Okay, they gave me time. This isn't going to be the yucky one. By the way, if you're wondering what the yucky one is, it's this one here where I don't give you the time. Instead, I make you hit the wall. I've been hitting the wall for a while, Mr. Dewick. No, you only feel like you've hit the wall. We're actually going to hit the wall in just a second, okay? That's as tough a question. That there is an A, maybe even kissing up to an A+ level question. So, don't write this down, don't write this down, don't write this down. I'm going to argue, Lydia, that to me, the velocity that we're trying to find either looks like that if it's on its way up, or it looks like that if it's on its way down. I'm going to draw. So I'm not going to dolp yet. Instead, why don't I find the vertical velocity after 4.6 seconds? And if it's positive, I'll know that it's on its way up. If it's negative, I'll know that it's on its way down. Okay. So before I dolp even, I'll put a little part A here. Over here, vertical, 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 vertical. So Vy initial was 82.693. Ay, negative 9.8. I'd like to find Vy final. Oh, thank God they gave me time. 4.6 seconds. I'm going to argue, by the way, if you all stay on this page, I'm willing to bet what I've just written looks really, really similar to what we did here. And yeah, it's getting repetitive, I hope. Which means I think I'm going to use Vf equals Vi plus At. I'm going to find that after 4.6 seconds, the vertical component is 82. Oh, you know what? I'm using my answer button because I have that stored. Plus negative 9.8 times 4.6. 37.613. I used my answer button. You might have a few different digits, but I'll go 37.613. Is that right? Hey, is it on the way up or on the way down? It's still on its and quite significantly. That's a pretty big vertical component still. What if it had been 0? By a fluke, I would have been exactly at the top. Okay. So how am I going to draw my velocity? On the way up. Did I just draw a slanty? You know what that's a job for? Component. When you're breaking it into components, when it's a velocity, it is worth doing horizontal then vertical. So all of our pictures look the same. And if your x comes before y, do it alphabetically. That's assuming you can remember that y is vertical and not horizontal. Not that I'm mentioning any names. Oh, he missed out on that. Okay. Oh, ooh. I can fill in Vx right now. 30.098. I can fill in Vy right now, not 82.693, but 37.613. Rylan, here's the mystery velocity. There's theta. How am I going to find the magnitude of the velocity? And I think Michael wants me to say, I think it's going to be tangent. I'm not even going to bother solve. I think you're okay doing the rest. We're not even going to go any further. I want to give you time to work on the homework, and I just wanted to let you know we can handle it. What I want to solve completely in time on this bad boy here. Is this bad boy here. Number 5, last question. Can you wait? Let's see if we can get a little bit repetitive. Ethan, what's this question asking me to find? Oh, a velocity. Look at the picture. Does it look like it's a slanty velocity? Okay. So, did I say slanty? And I'm going to know Vx. I'm probably going to have to find Vy final. Okay. I'm going to assume the picture is correct and that the velocity it hits the wall at, there's the velocity. Which means I'm going to break it up into Vx and Vy final. I've already got my strategy planned. Mr. Dewick, that looks really, really similar to this question and really, really similar to this question. All I'm doing is taking you one step further. What I didn't give you this time is time. All right. How would I start? And really, I probably should have done this first before I did anything else. Components. Did they give me a slanty velocity to begin with? Okay. So I'm going to break this up into Vx and by initial. Hey, Vx big function. Of course it is. Vx ends up being 26 cos 37. And Vy initial ends up being 26 37. 26 37. I get 20.765. 20.765. 0.765. And heck, I'll put that here. 20.765. V. I get 15.647. This be wrong. Even well, that's not Vy final. It's Vy initial. Okay. That, by the way, kids do that all the time. They drop this, and then they do Pythagoras. You know what they get? 26. And then they find theta. You know what they get? 37 degrees, because all they've done is they've written those components there. If you go back to the original vector, you'll get your original velocity. So I can't drop that. Oh, I need to calculate what Vy final is. Did I say y? Vertical. Do that over here. I want to find Vy final. Vy initial is 15.64. A is negative 9.8. T, oh. And now I'm going to pause and see for a candy if anyone can tell me what we can now try. Eric, speak. I think you're right. I haven't used this 40 yet, which is horizontal. So are you suggesting that, how about up here, I'm going to make a little horizontal column, and you're telling me I know AX is 0, right, Braden? I know VX is 20.765. I know that DX, the horizontal distance, is 40. Eric, are you telling me that I can find time with that? Eric, candy for you. Woohoo! Nope, sorry. Nice. Usually there's dead silence there. I always hope that someone sees it. Well, you see, it's in the picture. Oh, Brady, I'm coming back to you. This is what I asked you earlier. Hey, he's getting his formula sheet out. That's all it took. I don't know T. I don't know VI. I don't have an initial or a final. Is that what you said last time? It's not the one we want. Here, it's got to have a D in it. Yeah, keep going. And do I need to say the half IT squared? No. Did you just say VIT as though that was the shortened version of the equation? I apologize. I thought you were saying VF equals VI plus AT. You were right. I'm sorry. Candy for you later, but not right now. So, Braden, you're telling me I can go dx equals vxt? In fact, you're telling me time is that? Finding time horizontally is nicer because no quadratic equation, because the half advantage. That's what gave us the quadratic equation when the height of a cliff. If they give you the horizontal range time, it's a snap. It's the range of Vx. It's going to be 40 divided by 20.765. I get a time of flight of I'll call it 1.9263. And now, that down here, 1.9263. You all stay on your screen. I'm going to scroll back. Do we not now have exactly the same information, different numbers? Find VF, stick it on there, Pythagoras and tan. So all I've done, and again, hopefully I haven't really done anything new. I've just given you different clever ways that we can think about this. Hey, if they give me a range, I can do something with that. It's horizontal. By the way, this question, which I won't give you, telling you the range, I could have given you the height of the cliff. The only problem here is you'd end up solving a quadratic to find T, and you'd get two possible answers, because it could have hit the cliff on the way up, and it could have hit the cliff on the way down. I'm not going to do that, but hashtag nerd trivia, it's kind of cool. Vy final equals Vi plus AT. Vi 15.647. Go ahead. Plus negative 9.8 times. Oh, I'm going to use my answer button because it's stored. Typo at all? Negative 3.23. You know what? Let's carry some extra sig figs. 1. That's a good place to round off. 3.231. Let's try that again. 3.231. Dean, what happened to the negative? There it is. Yeah. And now, Pythagoras, and there's theta. It's going to hit the wall at a magnitude of 20.765 squared plus 3.231 squared. 0.0? Almost worked out evenly. That's at Michael, which trig function? You're kidding me. Tan theta. Let's do it a different color. Tan theta equals opposite 3.231 over adjacent 20.765. Shift tan of 3.231 divided by, excuse me, sorry for those of you on YouTube. You okay, Kareem? Good, shut up. Here we go. 8.8. You know what? It's almost level. It's barely started going down. So my drawing isn't great, but that's okay. Degrees. And how would I describe that direction? Below the horizontal. I'm not going to these questions for homework. I was going to take home quiz. I'm about to hand it out. 2, finish lesson 3. You can now do every question on the ultimate review that I handed out a couple of days ago. Video.